All right, this is the percent copper and formula weight of a copper compound lab. And I'm going to be doing 2 samples, but I'm only going to do one on camera, and then I'll give the results of the other. So here are the components that we'll need. There's a copper compound, and then hydrochloric acid, magnesium turnings, then we'll have the ethyl alcohol and the acetone, and then various other things, and we'll need to filter, and we're also going to dry out the sample in the oven. Okay, so we'll get started. So again, I'll just do one sample so I can focus on that, and then I'll present the data for the other sample. All right, we're gonna weigh our sample on the weighing boat, zero it out, and then gonna add the sample to it. Just lightly tap, make sure it's all set to go. And here's the mass of the sample. Okay, so we have our 150 ml beaker. I'm going to add the sample. And then add in 50 mils of distilled water. And then, I didn't quite finish filling this. I'm going to put in enough of the hydrochloric acid, 6 molar, to make 5 mils. And that goes in as well. And then what we want to do is get all the solid into solution. And it might take a little bit to get it all in there. But eventually, in this case, you'll have a nice blue solution. The copper 2 ion will be in solution and ready to be reacted. Okay, so we won't do 3 minutes or 4 minutes of me stirring this. You can see that it's going in, should mostly be in soon, but we'll start from there once it's all in solution. Okay, and while I'm waiting for the last of the copper sample to dissolve, I'm going to weigh out the magnesium turning. Should be about 0.4 grams. In this case, it doesn't have to be 0.454 is fine. You're not writing that down anywhere. You just don't want to have so much magnesium that once the reaction is over, you have to let the acid dissolve the rest of the magnesium for an hour. So about 0.4 grams will be plenty for our needs. And here's the reaction. So we got the magnesium that's going to go in, and the magnesium is going to be oxidized, and the copper ion is going to be reduced, and the copper will fall out of solution. Sometimes it floats on the surface, sometimes it falls to the bottom. There's all kinds of different things, but it definitely turns into copper. Now, as it reacts, I'm going to do it slowly, but might as well see the reaction there. Now, coming off of out of the beaker is hydrogen gas, but what is dragging with it is some of the acid fumes. So you got to be careful. Don't want to breathe that in. But you can see a little closer. See, it's turning red on top. That's the copper. And the copper's all covered with bubbles of hydrogen. That's why it's staying afloat, but eventually it falls to the bottom. And, ooh, you can smell it, so sit back here a little bit. Okay. Yeah, I think you can reach it from here. All right, so I'm going to just stir this. And there should be enough magnesium to react. If it turns out that when all the magnesium has reacted, it still has a blue or green color to the solution, I'll add a little bit more magnesium. If the reaction starts to slow down, I'll add a little bit more acid, but this part takes anywhere from about 10 to 15 minutes. So again, I won't take video of the entire thing. You can see it's fairly robust reaction. And you should see that the color is fading. It's still kind of blue, but it's looking more blue-green, and there's less and less color as we go along, but there's more and more copper, which makes sense. And the copper, there's now so much of it, it's falling to the bottom. You can see that it's being lifted by the hydrogen gas, and there's magnesium in there that's still reacting. Now when all the color is gone, when it just looks like water above, that means all the copper has been reduced. And then the bubbling is entirely due to the magnesium reacting with the hydrochloric acid. All right, so that's about 2 minutes. So we'll stop here and then come back when it's done. And as I said, I'll add more magnesium or acid as needed, but this is looking like it's going really well, so I don't think I'll have to do too much more except to wait. All right, while the reaction is going on, I'm just going to weigh the filter paper. See that I have put my name on it in pencil. Don't put it in pen, because the pen is going to dissolve in most of the solvents we use. So weigh out the filter paper and make sure you write your name on it before it gets wet. Oops, don't have this on. Oops. 0, and there's the mass of the filter paper, 1.198 grams. Okay, this is about 15 minutes in. Notice that there's no color to the solution. Looks like water. And all you can see is the copper on the bottom. Now there's bubbling because there's some magnesium left, but not a lot of bubbling. So I'm going to give it another 5 minutes or so. You can see appears to be nothing but copper in there. But the bubbles say there's a little magnesium left, so we'll let that react. And then after that, we will do the filtering. All right, now we're going to filter. So take the filter paper, fold it in half, and then fold it again. See if that look to it. Now you can see that there's 4 leaves. There are 4 sheets here, so take 3 of them on one side and then 1 on the other, and you get a coffee filter look to it. This goes into the long stem funnel that's on the clay triangle that's on the iron ring. Okay, and then to keep it in there, just put in a little bit of water, not a lot, you just want it to stick to the side. After that, we'll be putting in plenty to keep it stuck to the side. Let me just lower this down for a second. You see it, and then oops, the everything that comes out of the filter, we're going to leave the copper behind, and then the solution is going to go through into the beaker. Okay. All right, so let's filter this. So first, try to get some of this copper. Looks like I got none of it. That's a little bit better. It's going through pretty fast, so that's good. So I'm just stirring it around, trying to get it off the bottom of the beaker. It's hard to do from behind the camera here. Okay. Let it go through. Because you don't want to get the liquid over the filter paper, because it'll go behind it and you could get a lot of your sample that goes through. Okay. And no luck here. There we go. There's some of it. Okay. So I'm going to let the liquid level drop. Then I'm going to use a wash bottle to try to wash out the rest of that copper. Gonna have to wait. Okay, gonna the angle is really bad here because I'm behind the camera, but it's working. Okay, see that there's a little bit left in there. So let me see if I can't. There we go. Okay. Yeah, the trick is you don't want to be putting a gallon of water behind this. Yeah, looks clean. You know, and see now we just have to wait for that water to go through. So that'll be maybe 2 or 3 minutes. We'll come back. All right, here's the copper after the solution has gone through the filter paper. So it's moist, and there's probably some stuff on there that we want to get rid of that's not copper. So we're going to be washing it with ethanol and then acetone. So that will pretty much dissolve anything that could be on the copper. And then here's the solution that went through. We're going to put that in the waste. And then here is 5 mils of ethanol and then 5 mils of the acetone. So we're just going to wash off the copper with that, make sure any impurities are gone, and then we're hopeful that all that will be left is the copper with a sheen of acetone, which is very volatile. It will be vaporized very quickly when we put this in the oven to dry. Okay, first thing is going to be the ethanol. It says to drizzle. It actually says drizzle, which is a good term for it. Drizzle the ethanol onto the copper. And then there's just a little of this left. I think you can see it's dripping through there. And then we'll wait a second here for the ethanol to go through, and then we'll put in the acetone. Okay. So wait just a second. Most of it's gone. Okay. So this is 5 mils of the acetone that's going to go in. And then there's a little bit left here. Okay. And that's going through pretty quickly. So we'll let that go through, and it's going to be moist, but with just acetone, and then we're going to take the filter paper with the copper and what's left of the solvent and put that into the oven. You can see that the copper is relatively dry. All the acetone has gone through. And I'm going to pick this up with forceps. Oops. Come on. There we go. And put it down on the watch glass. And then I'm going to, I got to get some gloves on because this has acetone all over it. I'm going to open this up, and then I'll show you putting this into the oven. Okay, here's the oven, and here's the sample. Oops. Just gonna put it here. It says it's at a I was dropping, but it was around 120 degrees Celsius. And I'm just going to put this in here. I'm going to give it 20 minutes just to be sure. All that's only liquid on there should be acetone, so that's going to dry very quickly. But we'll give it 20 minutes and see what we get. Okay, I'm going to use my Kevlar glove to get this out. Just going to take the filter paper, set it down, and get this out of here. Okay. Take a look. Here's dry, and yeah, definitely no moisture left in there. So we are ready to weigh. All right, we'll weigh the sample. And I shouldn't mention that I only put it into the oven once, but I had it in there for well over 20 minutes actually. So that's plenty of time for it to get dry. So I only did one heating. So it gives you two places for the heating, the first heating and the second, but I only did one. And here is the mass of the sample, 2.176.